In the diagram below, the two circles intersect at A and B. The equation of AB is given by 2y equals x plus 3. Mn, a diameter of the larger circle, has equation 6y equals x minus 20. The equation of the smaller circle is given by x squared plus 2x plus y squared minus 6y equals 6. We are required to show that the point A does not lie on the x-axis. And we are required to determine the center of the larger circle. We are told that the two circles intersect at points A and B. If point A does indeed lie on the x-axis, then the y-coordinate of point A must be 0, since that is the definition of an x-intercept. So, to determine the coordinates of points of intersection, we equate two functions. We cannot equate the two circles, because we do not know the equation of the larger circle. We were, however, given the equation of line segment AB, so we can equate this line to the equation of the smaller circle, to determine the coordinates of points A and B. So, equating the line AB and the smaller circle, we get y equals 3, or y equals minus a fifth. Neither of these solutions for y give a value of 0. If the y-coordinate of any point is 0, it implies that that point is an x-intercept. Since neither y value is 0, it implies that neither of the points, A or B, can possibly be an x-intercept. Although the diagram is not drawn to scale, it is clear that the only point that could have been an x-intercept is point A. The y-coordinate of point B is therefore 3, as point B lies above the x-axis, where y values are positive. It therefore stands to reason that the y-coordinate of point A is minus a fifth. If point A were to be an x-intercept, its y-coordinate would have to be 0, which it isn't. Alternatively, to show that point A is not an x-intercept, we can first determine the x-intercept of line segment AB, before determining the x-coordinate of point A. The x-intercept of line segment AB is the point minus 3, 0. Now, substitute y equals x plus 3 all over 2 into the equation of the smaller circle. Solving for x gives us x equal 2 minus 17 over 5, or x equals 3. Since point A lies to the left of the origin, its x-coordinate is minus 17 over 5, which is clearly not minus 3. Point A does therefore not lie on the x-axis, since the x-intercept of line segment AB is the point minus 3, 0. We don't know much about the larger circle, other than the fact that the points A and B lie on the circumference of the circle. It is therefore a good idea to start by determining the coordinates of points A and B. We have already determined the y-coordinates of these 2 points, so we simply need to determine their respective x-coordinates by substituting these 2 y values into the equation of either the line AB or the smaller circle. The coordinates of point A are therefore minus 17 over 5, minus 1 over 5. And the coordinates of point B are 3, 3. To determine the center of the larger circle, we can formulate 2 equations by finding 2 expressions relating the points A and B to the center of the circle via the distance formula. So, the length of AO equals the length of BO, since both line segments are radii of the circle and radii of a circle are equal. Simplifying the resultant expression gives us y equal 2 minus 2x plus 1. We can now equate the expression y equals minus 2x plus 1 to the expression 6y equals x minus 20 and solve the 2 equations simultaneously. The center of the circle is therefore the point 2 minus 3. Determining the center of the circle, the way we just did, is quite time-consuming. So an even better way of determining the center of the circle is to first determine the midpoint of line segment AB, then determine the equation of the line segment PO, and finally equating the equation of PO to the equation of the diameter of the larger circle. The reason for determining the midpoint of line segment AB is because AB is a chord of the larger circle, and by determining the midpoint of this chord, we can determine the equation of the line segment joining the center of the larger circle to this midpoint by using the midpoint-chord theorem. So, the midpoint of AB is -1/5, 7/5. To determine the equation of PO, we need to know the gradient of PO. Since PO is perpendicular to chord AB, we can determine the gradient of PO by first determining the gradient of AB. The gradient of AB equals 1/2. And since PO is perpendicular to AB, it follows that the gradient of PO is -2, since the product of the gradients of two perpendicular lines is -1. To determine the equation of PO, we of course use the point P and the value of the gradient of PO. The equation of PO is therefore y equals -2x plus 1. Finally, we can equate these two equations as they intersect each other at the center of the larger circle. The center of the larger circle is therefore 2 minus 3.